Dear students, I am Hiba Haq, lecturer of physics from Government Degree College, Malir, Cantt, Karachi. So this lecture is about phenomenon of a sound wave, which is a topic from chapter number 8, first year syntax book. I have already explained what are longitudinal waves and then how sound wave propagate, and I have calculated the value of speed of sound in air in my previous lecture. Under this lecture I shall explain superposition of sound waves. After that, musical sounds, in which I will explain few quantities that are used to explain musical sounds. Then after that, beats, which is one of the most important topics from chapter number 8, and at the end I will explain acoustic. Okay, so let's start with superposition of sound waves. According to the principle of superposition, when two or more waves in the same linear medium travel, the net displacement of the medium caused by the resultant wave at any point is equal to the algebraic sum of the displacements of all waves. When two or more waves are traveling in a linear medium, the net displacement at any point is actually the algebraic sum of all the displacement of wave at that point. So to understand it further, consider two waves are traveling in the same direction and have same frequency, amplitude and wavelength, but they are in different phase. So we consider y1 xt as the displacement of first wave, which is equal to a naught sine kx minus omega t, and y2 xt is the displacement of second wave, which is equal to a naught sine kx minus omega t minus y. So note that the amplitude a naught is same, then k wave number, which depend upon the wavelength, is same, then omega angular frequency, which depend upon the frequency, is same, but we have this phi, which is the phase difference, and this phase difference will explain, or the value of this or constructive interference or destructive interference depends upon the value of this phase difference. So here we have two waves moving in same direction, having same amplitude and frequency, but different phase. So when they overlap or superimpose in such a way that if the phase difference is 0 or m pi, which means that if they are in phase, we get constructive interference, which means maximum amplitude, and if the phase difference is n plus half pi, or they are out of phase, we get destructive interference and minimum amplitude. So for constructive interference, crest of first wave falls on the crest of second wave and they add up to, and if you talk about destructive, the crest of first wave falls on the trough of the second wave, or vice versa. So now what we do, we try to calculate the resultant of these two waves. So superposition is actually defined or explained using mathematical expression. So in this lecture you will see lot of maths. The resultant of wave function yxt is equals to y1 xt plus y2 xt. Now putting the value of y1 and y2, yxt is equals to a naught sine kx minus omega t plus a naught sine kx minus omega t minus phi. So again this is similar with the formula sine a plus sine b, which is equal to 2 sine a plus b upon 2 into cos a minus b upon 2. So if we take a naught constant, we get sine k a naught into bracket into sine kx minus omega t plus sine kx minus omega t minus phi. So here we have a is equal to kx minus omega t and b is equal to kx minus omega t minus phi. Now expand it using this formula. Yxt is equals to 2 a naught into 2 sine kx minus omega t plus kx minus omega t minus phi upon 2 into cos of kx minus omega t minus kx plus omega t plus phi. We will multiply this bracket with the negative, so this positive plus positive will become negative, and these two negative will become positive. So this kx cancel, omega t cancel, and here we have kx plus kx 2 kx, omega t plus omega t 2 omega t. So y of xt is equals to 2a0 into sine 2kx minus 2 omega t minus phi upon 2 into cos phi by 2, or y of xt is equals to 2a0 sine. If you divide 2kx up by 2, we get kx, 2 omega t by omega 2, we get omega t, and then minus phi by 2. So we get kx minus omega t minus phi upon 2 into cos phi by 2. The amplitude of the resultant wave is 2a0 cos phi by 2. Now we try to find on what conditions we get maximum amplitude and minimum amplitude. So for maximum amplitude or constructive interference, cos of phi by 2 should be equal to 1, and phi by 2 is equal to cos inverse of 1, and then phi by 2 is equals to 0, pi, 2 pi, 3 pi up to m pi, where cos theta is again a periodic function and its values oscillate between plus 1 and minus 1. So at 0 its value is 1, and at 90, which is pi by 2, its value is 0, and after 360 degree or 2 pi radian, cos theta will repeat its value. So for maximum amplitude, phi by 2 should be equal to 0, pi, 2 pi, 3 pi up to m pi, where m is 0, 1, 2, 3 up to integers. And then if we talk about minimum amplitude or destructive interference, cos phi by 2 should be 0, or phi by 2 should be equal to cos inverse of 0, and cos inverse of 0 is at pi by 2, 3 pi by 2, 5 pi by 2 up to n plus half pi by 2, where n is again 0, 1, 2, 3 up to so on. So here we have the explanation of maximum amplitude and minimum amplitude. These are two waves. So when these two waves are in phase, which means that the phase difference between them is 0, then pi, then 2 pi, 3 pi up to so on, we get a constructive interference, or we get a maximum amplitude. And when they are out of phase, which or phase difference phi by 2 is equal to 0, pi by 2, 3 pi by 2 up to so on, we get destructive interference. And in destructive interference we get 0 amplitude, 0, and in constructive interference we get maximum amplitude. So let us discuss the final expression. The resultant wave function also have the same frequency, amplitude and wavelength, and then we have the amplitude of resultant wave is 2a0 cos phi by 2, and its phase is equal to phi by 2, and if phi is 0, cos phi by 2 is equal to 1, which means that the amplitude will be 2a0, since cos of 0 upon 2 is equal to 0, so cos 0 is 1. For constructive interference, we have cos phi by 2 is equal to plus minus 1, which means phi by 2 is equal to 0, pi, 2 pi, 3 pi up to n pi. Or if we talk about just phi will be equal to 0, then if you multiply 2 with pi, you get 2 pi, then 2 with pi, 2 pi we get 4 pi, 6 pi up to 2n pi. And if we talk about the destructive interference, it takes place at when cos of phi by 2 is 0, which means that phi by 2 is equal to pi by 2, 3 pi by 2, 5 pi by 2 up to n plus half pi. Or if we talk about just phi will be equal to 0, pi, 3 pi, 5 pi up to 2n plus 1 pi. You just multiply this whole by 2 to get the value of phi. After superposition of sound, let's talk about musical sound, and in this first I'm going to explain pitch and frequency. So the pitch of a note is the position of in the musical scale that depends on the frequency of vibration of its source, and frequency is number of vibration in 1 second. So pitch is actually depend upon the frequency of vibration of the source of sound. Then if you talk about music and noise, a sound of regular frequency is called a tone or musical note, and music is a combination of such sound. So music is actually a combination of sound waves having regular frequency, and noise is a sound or a combination of sounds of constantly varying pitch or regular frequency. Musical interval, the ratio of the frequencies of two notes, is called as musical interval. Now if you talk about intensity and loudness of sound, so the intensity of sound of a sound wave is defined as the rate of flow of energy per unit area perpendicular to the direction of the wave. Intensity is actually energy per unit area per unit time, so energy E upon A into T, and it is measured in watt per meter square. Since energy per unit area is watt, the energy per unit time is watt, rate of doing work is power, so unit of power is watt, so we get watt per meter square. Mathematically, it is found that sound intensity of a sound is proportional to the density of air, then the square of the frequency and the square of the amplitude. And if we talk about loudness, loudness of a sound depends upon the intensity of sound, but it does not follow that loudness is directly proportional to intensity. According to Weber-Fechner law, loudness is directly proportional to log of intensity. Now, intensity level is the difference between the loudness of two different intensities. So if we have I and I naught intensities, then intensity level is equal to log of I minus log of I naught, or we know that log of A minus log of B is equal to log A upon B, so intensity level is equal to log I upon I naught, where I naught is equal to 10 raised to the power minus 12 watt per meter square, and it is the least intense sound that a normal human ear can record. Now if you talk about few units, decibel is a unit used to measure the intensity of a sound by comparing it with a given level on a logarithm scale. Then bell is a unit of unit of measure equal to 10 decibels. So 1 bell is equal to 10 decibel, and then swan is an arbitrary set equal to the loudness of a 1000 hertz tone at a sound level of 40 decibels. So one swan is equal to 40 decibels at 1000 hertz. Now, quality of a sound is that characteristic which distinguishes the two sounds of the same loudness and same pitch, but emitted by two different instruments. So, musical sound is an important topic for MCQs, as you have a very small little informations in it that definitely can be asked in MCQs. Now, let's talk about beats. Beats are fluctuations in amplitude produced by two sound waves of slightly different frequency, or the periodic variation in intensity at a given point due to superposition of two waves having slightly different frequency. So the difference between beat and interference is that in interference the frequency of the two waves should be same, but in beats the frequency of two waves is slightly different. So when two waves of different frequencies arrive at the same point and superimpose, they alternatively constructively and destructively interfere, causes the sound to be alternatively soft and loud. The phenomena is called beating or producing beats. The maximum beat frequency that a human ear can detect is about 7 beats per second. So now we are going to drive the expression for the beats. For that, consider two waves or with equal amplitude traveling through a medium in the same direction having slightly different frequency. So here we have two waves of equal amplitude but different frequencies and moving in the same direction. When they superimpose, then we get constructive and destructive interference, so we will see it later. Okay, y1 xt is the displacement of first wave, which is equal to a naught cos 2 pi f1 t, and y2 xt is the displacement of second wave, which is equal to a naught cos 2 pi f2 t. So note that a naught is constant, same which is the amplitude, but frequencies are different, so we take y f1 and f2. Now the resultant wave function y xt is given by yxt is equals to y1 xt plus y2 xt. Putting the value of y1 xt, y2 xt, a naught cos 2 pi f1 t plus a naught cos 2 pi f2. t, or we can write it as a naught bracket cos 2 pi f1 t plus cos 2 pi f2 t. So this is similar to a trigonometric formula, cos a plus cos b, which is equal to 2 cos a plus b upon 2 into cos a minus b upon 2. So here a is equal to 2 pi f1 t and b is equal to 2 pi f2 t. Expand this using this formula, y x t is equals to a naught 2 cos 2 pi f1 t plus 2 pi f2 t upon 2 into cos 2 pi f1 t minus 2 pi f2 t upon 2, or y x t is equals to 2 a naught cos, taking 2 pi t common, 2 pi t f1 plus f2 upon 2 into cos 2 pi t f1 minus f2 upon 2. So here we have a diagram. This is the wave 1 with frequency f1, and this is the wave 2 with frequency f2, such that f1 is slightly greater than f2. So when they combine in such a way that they are in phase, which means that their phase difference is 0, then we get the maximum amplitude and we get constructive interference. And when they are out of phase, which means that the phase difference between them is 180, then we get minimum amplitude or 0. And then we have in phase, then we get maximum, and then amplitude, then for out of phase we get 0, and so on. Okay, and now in this expression, y x t 2 a naught cos 2 pi t into f1 plus f2 upon 2 into cos 2 pi t f1 minus f2 upon 2. So this f1 minus f2 is actually the beat frequency, and this f1 plus f2 upon 2 is the average frequency. So if we talk about beat frequency, it is number of beats produced per second, and it is equal to the difference of the frequencies of two waves. So now let us discuss this final expression. So in this expression, the resultant displacement has an effective frequency equal to the average frequency, which is f1 plus f2 upon 2. Now the amplitude of the resultant wave is 2a cos 2 pi t f1 minus f2 upon 2, and the amplitude varies with frequency f1 minus f2 upon 2, where f1 minus f2 is the beat frequency. Now if you talk about the maximum amplitude, for maximum amplitude cos 2 pi t f1 minus f2 upon 2 should be equal to plus minus 1. So in this condition we get constructive interference, so which means that 2 pi t f1 minus f2 upon 2 should be equal to n pi, where n is 1 2 3 up to so on. And if we talk about minimum amplitude, or for destructive interference, cos 2 pi t f1 minus f2 upon 2 is equal to 0. So we can further say it as that 2 pi t f1 minus f2 upon 2 should be equal to n plus half into lambda, where n again is equal to 1 2 3 4 up to so on. So this is the discussion of the final result, and whenever we have to calculate the beat frequency, we just take the difference of the frequency, two given frequencies. Now the last topic, acoustic. Acoustic is a science concerned with the production, control, transmission, reception and effect of sounds. So acoustic actually relates with the reproduction of sound. The reproduced sound may be indistinct and confusing, or it may also be clear and distinct. When sound waves travel through a medium, they reflect, transmit and absorb by the material they encounter. So to understand this, let us consider an example. That let us consider that sound waves are produced in a big hall. These sound waves spread out, scatter and strike the surface of the wall, floor, on the various objects present in the hall. Some of the sound waves is absorbed by the surface and some is reflected. The reflected part travel back and recombine to form undesirable echo. So these echoes interfere with the original sound wave coming directly from the source. The result is that we have an indistinct sound, that and hence give rise of a bad acoustic. So when a sound wave travels through a medium, it reflect, absorbed and diffuse. So reflection we means most of the sound is reflected, which is almost as loud as incoming sound. And if we talk about absorption, absorption power is determined by the material used. Then we have diffusion, scattered sound depending on the desired effect. And here we have the direct sound, and then this direct sound is absorbed by the material of a medium present in the hall. And then we have the reflection, and then we have the diffusion. So due to these three processes, the sound wave will when reflect back, it recombine to form an echo, and this echo will uh, this echo interferes with the original sound, and which cause an undesirable or indistinct sound. So how we can overcome this problem? Condition for good acoustic is that the quality of speech and the music remain unchanged in each and every portion of hall. Then the sound produced must be sufficiently loud. And then we have echo should be just sufficient to maintain the continuity of sound. There should be uniform sound distribution in every portion of the hall. Then the walls should be soundproof to avoid external noise in the hall. So using these techniques, we can overcome the bad acoustic. So this is all about my today's lecture. In today's lecture, we learn how sound wave behave when they propagate through a material medium, which include few phenomenons, and I explain superposition of sound waves. Then after that, I explain few quantities, terms that are used to explain a musical sound. After that, I will discuss beats, and in the end I will explain acoustic, and what are the conditions for good acoustic. So I will end up my lecture on the words of Isaac Newton. He once said that if I have done the public any service, it is due to my patient thought. Thank you. If you have any question, feel free to ask. I will try my best to answer it. God bless you. Take care.